When running two 12/2 underground feeder cables from inside one outbuilding to two smaller outbuildings, and those cables enter the main outbuilding through a 1/2-inch polyvinyl chloride, also known as PVC, LB connector and conduit on the outside, the National Electrical Code, also known as NEC, dictates whether a junction box is needed or if a collared nipple on the inside of the wall is sufficient for the cable to pass through to the main panel. According to the NEC, a junction box is required when there are more than 4 wires entering a box. Given that you have 2 cables, each containing 3 wires, specifically 2 conductors and a ground wire, the total number of wires entering the main outbuilding amounts to 6. Consequently, a junction box becomes a mandatory component in this electrical setup. The primary purpose of a junction box is to furnish a secure and readily accessible location for the connection and splicing of wires. This accessibility is crucial for facilitating inspections and ensuring ease of maintenance within the electrical system. A collared nipple, in contrast, is deemed inadequate for this application because it fails to provide a secure or accessible location for connecting the wires. Furthermore, its utilization does not align with the NEC requirements for a junction box in situations involving multiple wires. In essence, the NEC mandates the use of a junction box in scenarios where the number of wires entering a box exceeds 4. This requirement is rooted in safety considerations and the need for organized and accessible electrical connections. The junction box serves as a centralized point for managing and protecting these connections, thereby reducing the risk of electrical hazards and simplifying future maintenance or repairs. The key considerations are firstly wire count. The NEC specifies the maximum number of conductors allowed in a box based on its size. In this scenario, with 6 wires entering the outbuilding, a junction box is necessary to accommodate the connections safely. Secondly, safety. Junction boxes protect the connections from environmental factors, accidental damage, and provide a fire-resistant enclosure. Thirdly, accessibility. Junction boxes allow for easy inspection, testing, and maintenance of the electrical connections. Fourthly, code compliance. Using a junction box ensures compliance with NEC standards, which are designed to protect people and property from electrical hazards. Now let's discuss the specifics of the underground feeder cable. Underground feeder cable, often abbreviated as UF cable, is a type of electrical cable specifically designed for direct burial in the ground. It is commonly used for supplying power to outbuildings, landscape lighting, and other outdoor applications. Understanding the characteristics and proper installation of UF cable is essential for ensuring safe and reliable electrical connections. UF cable consists of insulated conductors encased in a moisture-resistant outer jacket. The conductors are typically made of copper or aluminum and are available in various sizes, such as 12 American wire gauge, abbreviated as AWG, 10 AWG, and 8 AWG, depending on the current carrying capacity required for the intended application. The outer jacket is made of a durable thermoplastic material that provides protection against moisture, chemicals, and physical damage. When installing UF cable, it is important to follow the manufacturer's instructions and all applicable electrical codes. The cable should be buried at the proper depth, typically 18 to 24 inches, to protect it from damage from digging or other activities. It should also be protected from physical damage where it exits the ground or enters a building. This is often accomplished by running the cable through conduit. When connecting UF cable to electrical boxes or equipment, use fittings and connectors that are specifically designed for use with UF cable. These fittings provide a watertight seal to prevent moisture from entering the connections. It is also important to properly ground the cable to protect against electrical shock. Now let's consider the National Electrical Code. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and published by the National Fire Protection Association, abbreviated as NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, contractors, and other electrical professionals to be familiar with the NEC and to follow its requirements when installing electrical systems. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. It provides detailed requirements for the materials, equipment, and methods used in electrical work. The NEC also includes tables and examples to help clarify the requirements and to provide guidance for specific situations. One of the key principles of the NEC is to ensure the safety of people and property from electrical hazards. It sets minimum standards for electrical installations to reduce the risk of fire, electric shock, and other hazards. The NEC also promotes uniformity in electrical installations, making it easier to inspect and maintain electrical systems. When interpreting and applying the NEC, it is important to consult the latest edition and to seek guidance from qualified electrical professionals. The NEC can be complex and may require interpretation to apply to specific situations. It is also important to be aware of any local amendments or regulations that may modify or supplement the NEC requirements. Now let's consider the role of a junction box. A junction box is an enclosure used to house electrical connections. It provides a safe and convenient location for splicing wires, connecting devices, and terminating circuits. Junction boxes are typically made of metal or plastic and are available in various sizes and shapes. They are used in a wide range of electrical applications, from residential wiring to industrial control systems. One of the primary purposes of a junction box is to protect electrical connections from environmental factors such as moisture, dust, and physical damage. It also provides a fire-resistant enclosure to contain any potential arcing or sparks. Junction boxes also make it easier to access and maintain electrical connections. They allow for easy inspection, testing, and troubleshooting of circuits. Junction boxes also provide a convenient location for adding or modifying circuits in the future. When selecting a junction box, it is important to consider the number and size of the wires that will be entering the box. The NEC specifies the minimum size of junction boxes based on the number and size of conductors. It is also important to choose a junction box that is appropriate for the environment in which it will be installed. For example, a weatherproof junction box should be used in outdoor locations or in areas that are subject to moisture. When installing a junction box, it is important to follow the manufacturer's instructions and all applicable electrical codes. The box should be securely mounted and the wires should be properly connected and terminated. It is also important to ensure that the box is properly grounded. Now let's talk about using a collared nipple. A collared nipple is a short length of threaded pipe that is used to connect electrical boxes or enclosures. It is typically used to provide a rigid connection between two boxes or to extend a box from a wall or other surface. Collared nipples are available in various sizes and materials such as steel, aluminum, and PVC. While a collared nipple can be useful in certain electrical installations, it is not a substitute for a junction box in situations where multiple wires need to be connected or spliced. A collared nipple does not provide the same level of protection or accessibility as a junction box. It also does not meet the NEC requirements for a junction box in many situations. In the specific scenario described in the question, using a collared nipple instead of a junction box would not be code compliant. The NEC requires a junction box when there are more than 4 wires entering a box. A collared nipple would not provide sufficient space or protection for the connections. Now let's address the specifics of wiring safely with underground feeder cables. When working with electrical wiring, safety should always be the top priority. Electrical work can be dangerous if not performed correctly. It is important to follow all applicable electrical codes and safety precautions to prevent electrical shock, fire, and other hazards. Before starting any electrical work, it is important to disconnect the power to the circuit you will be working on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to test the circuit to make sure that it is de-energized before touching any wires or equipment. When working with wires, it is important to use the proper tools and equipment. Wire strippers should be used to remove the insulation from the wires without damaging the conductors. Wire connectors should be used to make secure and reliable connections between wires. It is also important to wear appropriate personal protective equipment, such as safety glasses and rubber gloves. When working with UF cable, it is important to handle the cable carefully to avoid damaging the outer jacket or the conductors. The cable should be protected from physical damage during installation. It should also be properly supported to prevent stress on the connections. When connecting UF cable to electrical boxes or equipment, use fittings and connectors that are specifically designed for use with UF cable. These fittings provide a watertight seal to prevent moisture from entering the connections. It is also important to properly ground the cable to protect against electrical shock. Now let's consider the consequences of not using a junction box when it is required. Failing to use a junction box when required by the NEC can have serious consequences. It can create a safety hazard, increase the risk of electrical fire, and result in code violations. One of the main risks of not using a junction box is that the electrical connections may be exposed to environmental factors such as moisture and dust. This can lead to corrosion, short circuits, and other problems. Exposed connections can also be a safety hazard, as they can be easily touched or damaged. Another risk of not using a junction box is that the electrical connections may not be properly supported or protected. This can lead to stress on the connections, which can cause them to loosen or break over time. Loose or broken connections can create a fire hazard. In addition to the safety risks, not using a junction box can also result in code violations. Electrical inspectors can issue fines or require the work to be redone if it does not comply with the NEC. Code violations can also affect the insurance coverage for the property. Therefore, it is always important to follow the NEC requirements and to use a junction box when it is required. Now, let's briefly discuss other types of electrical boxes. In addition to junction boxes, there are several other types of electrical boxes that are used in electrical installations. Each type of box is designed for a specific purpose and has its own unique features. Some common types of electrical boxes include outlet boxes, switch boxes, and pull boxes. Outlet boxes are used to house electrical outlets and receptacles. They are typically mounted in walls or ceilings and are used to provide power to appliances, lighting, and other electrical devices. Switch boxes are used to house electrical switches. They are typically mounted in walls and are used to control lighting, fans, and other electrical devices. Pull boxes are used to provide access to electrical conductors for pulling or splicing. They are typically used in long conduit runs or in situations where there are multiple bends in the conduit. When selecting an electrical box, it is important to consider the type of device that will be installed in the box, the number and size of the wires that will be entering the box, and the environment in which the box will be installed. Now let's consider the importance of professional installation. While it may be tempting to perform electrical work yourself, it is generally recommended to hire a qualified electrician for any electrical work that is beyond your skill level. Electrical work can be dangerous if not performed correctly, and it is important to follow all applicable electrical codes and safety precautions. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and effectively. They can also ensure that the work complies with all applicable electrical codes. Hiring a qualified electrician can also save you time and money in the long run. They can identify potential problems early on and prevent costly mistakes. They can also ensure that the electrical system is properly installed and maintained, which can extend its lifespan and reduce the risk of future problems. In summary, when running two 12/2 underground feeder cables from inside one outbuilding to two smaller outbuildings, and those cables entered the main outbuilding through a 1/2-inch PVC LB connector and conduit on the outside, the NEC requires the use of a junction box due to the number of wires exceeding 4. This requirement is in place to ensure safety, accessibility, and compliance with electrical codes. Using a collared nipple is not a sufficient substitute for a junction box in this scenario. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns about electrical work. Now let's consider some further details about selecting the correct size of junction box. The NEC provides specific guidelines for determining the minimum size of junction boxes based on the number and size of conductors that will be housed within them. These guidelines are essential to ensure that there is adequate space for the wires to be properly installed and to prevent overcrowding, which can lead to overheating and other safety hazards. The NEC uses a system of fill calculations to determine the minimum box size. This involves calculating the total volume occupied by the conductors, devices, and fittings within the box, and then comparing this volume to the available volume of the box. The NEC provides tables that list the volume occupied by different sizes of conductors and devices. To determine the minimum box size, you will need to know the following information. Firstly, the number and size of the conductors entering the box, including the neutral and grounding conductors. Secondly, the number and type of devices that will be installed in the box, such as switches, receptacles, and connectors. Thirdly, the number and size of any fittings that will be used in the box, such as cable clamps and connectors. Once you have this information, you can use the NEC tables to calculate the total volume occupied by the conductors, devices, and fittings. Then, you can select a box that has a volume that is equal to or greater than the calculated volume. It is important to note that the NEC also specifies the minimum dimensions of the box, in addition to the minimum volume. The box must be large enough to allow for the proper installation and termination of the conductors and devices. In some cases, it may be necessary to use a larger box than the calculated minimum size to meet the dimensional requirements. In addition to the NEC requirements, it is also important to consider the practical aspects of selecting a junction box. The box should be easy to install and access, and it should be made of a durable material that can withstand the environmental conditions in which it will be installed. It is also important to choose a box that is appropriate for the type of wiring method being used. For example, if you are using non-metallic sheet cable, you will need to use a non-metallic box. If you are using metal conduit, you will need to use a metal box. Now let's discuss grounding requirements for electrical systems. Grounding is an essential safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and energize the circuit in the event of a ground fault. Grounding also helps to reduce the risk of electric shock by providing a reference point for voltage. The NEC specifies detailed requirements for grounding electrical systems. These requirements cover a wide range of topics, including the types of grounding electrodes that are permitted, the size of the grounding conductors, and the methods for connecting the grounding conductors to the grounding electrodes. One of the key requirements is that all electrical equipment and wiring systems must be properly grounded. This includes metal enclosures, conduit, and cable trays. The grounding conductors must be sized according to the NEC tables and must be connected to a grounding electrode system that meets the NEC requirements. The grounding electrode system typically consists of one or more grounding electrodes, such as a ground rod, a metal water pipe, or concrete encased electrode. The grounding electrodes must be properly installed and must have a low resistance to ground. In addition to the equipment grounding requirements, the NEC also specifies requirements for system grounding. System grounding involves grounding the neutral conductor of the electrical system. This is typically done at the service entrance, where the power enters the building. System grounding helps to stabilize the voltage and reduce the risk of voltage fluctuations. It also provides a path for fault current to flow back to the source in the event of a ground fault. It is important to note that grounding is not the same as bonding. Grounding provides a path for fault current to flow back to the source, while bonding connects metal parts together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. Now let's discuss overcurrent protection in electrical systems. Overcurrent protection is another essential safety measure in electrical systems. It is designed to protect the wiring and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds a safe level. The NEC specifies detailed requirements for overcurrent protection. These requirements cover a wide range of topics, including the types of overcurrent protection devices that are permitted, the size of the overcurrent protection devices, and the methods for installing the overcurrent protection devices. One of the key requirements is that all electrical circuits must be protected by overcurrent protection devices. The overcurrent protection devices must be sized according to the NEC tables and must be installed in a readily accessible location. The overcurrent protection devices must also be properly rated for the voltage and current of the circuit they are protecting. In addition to the circuit protection requirements, the NEC also specifies requirements for equipment protection. Equipment such as motors, transformers, and appliances must be protected by overcurrent protection devices that are sized according to the NEC tables. The overcurrent protection devices must be installed in a location that is readily accessible and must be properly rated for the voltage and current of the equipment they are protecting. It is important to note that overcurrent protection devices are not designed to protect people from electric shock. They are designed to protect the wiring and equipment from damage caused by excessive current flow. Ground fault circuit interrupters, also known as GFCIs, are used to protect people from electric shock. Now let's explore different wiring methods for electrical systems. The NEC recognizes a variety of wiring methods for electrical systems. Each wiring method has its own unique characteristics and is suitable for different applications. Some common wiring methods include non-metallic sheath cable, metal-clad cable, electrical metallic tubing, electrical non-metallic tubing, and rigid metal conduit. Non-metallic sheath cable, often referred to as NM cable, is a type of cable that consists of insulated conductors encased in a non-metallic jacket. NM cable is commonly used in residential wiring for branch circuits and feeders. It is relatively inexpensive and easy to install. Metal-clad cable, often referred to as MC cable, is a type of cable that consists of insulated conductors encased in a metal sheath. MC cable is commonly used in commercial and industrial wiring for branch circuits and feeders. It provides better protection against physical damage than NM cable. Electrical metallic tubing, often referred to as EMT, is a type of thin-walled metal conduit. EMT is commonly used in commercial and industrial wiring for branch circuits and feeders. It provides good protection against physical damage and can be easily bent and cut. Electrical non-metallic tubing, often referred to as ENT, is a type of flexible non-metallic conduit. ENT is commonly used in residential and commercial wiring for branch circuits and feeders. It is lightweight and easy to install. Rigid metal conduit, often referred to as RMC, is a type of heavy-walled metal conduit. RMC is commonly used in industrial wiring and in locations where there is a high risk of physical damage. It provides the best protection against physical damage and is also resistant to corrosion. When selecting a wiring method, it is important to consider the application, the environment, and the NEC requirements. The wiring method must be suitable for the type of circuit, the voltage and current of the circuit, and the environmental conditions. It is also important to follow the NEC requirements for the installation of the wiring method. Now, let's discuss the inspection process for electrical installations. Electrical inspections are an important part of ensuring the safety and compliance of electrical installations. Electrical inspectors are responsible for verifying that electrical work is performed in accordance with the NEC and other applicable codes and standards. The inspection process typically involves a review of the plans and specifications for the electrical installation, followed by a visual inspection of the work. The inspector will check for compliance with the NEC requirements for wiring methods, overcurrent protection, grounding, and other aspects of the installation. If the inspector finds any violations of the codes or standards, they will issue a notice of violation and require the work to be corrected. Once the corrections have been made, the inspector will re-inspect the work to verify that it complies with the codes and standards. In some cases, the inspector may also perform tests to verify the proper operation of the electrical system. It is important to cooperate with the electrical inspector and to provide them with access to the electrical installation. The inspector is there to ensure the safety and compliance of the installation, and our work is essential for protecting people and property from electrical hazards. Now, let's briefly address the importance of ongoing maintenance for electrical systems. Electrical systems require ongoing maintenance to ensure their safe and reliable operation. Regular maintenance can help to identify and correct potential problems before they lead to failures or safety hazards. Some common maintenance tasks for electrical systems include inspecting wiring and connections for damage or corrosion, testing of current protection devices to verify their proper operation, and cleaning electrical equipment to remove dust and debris. It is also important to periodically check the grounding system to ensure that it is properly connected and that the grounding electrodes are in good condition. The frequency of maintenance will depend on the type of electrical system and the environment in which it is located. For example, electrical systems in harsh environments may require more frequent maintenance than electrical systems in mild environments. It is generally recommended to have electrical systems inspected and maintained by a qualified electrician on a regular basis. A qualified electrician can identify potential problems and perform the necessary repairs to keep the electrical system operating safely and reliably.